Alright guys, in this video I want to try to help you to understand strong acids and strong bases and what they all mean as far as being strong and weak. Now, there technically exists only 6 strong acids and 8 strong bases. That's it. Okay, now what do we mean when we say strong? Okay, strong acids and strong bases are considered strong because once they go into water, 100% they break apart into ions completely. They dissociate, meaning break apart, 100%. That's what strong acids and strong bases are. For example, if you had HCl and you were to throw this hydrochloric acid into water, what you would have to happen is you would have the hydrogen to separate from the chloride ion, and the H become H plus 1, and the chlorine would become Cl negative 1. So they just split apart, and that happens to this one, this one, this one, this one, this one, and this one. Now let's at least look at H2SO4. If it were to hit water just as HCl, it too would split apart into ions. Okay, you would have the H plus 1 going off, and you would have the SO4 negative 2 going off. But the only thing is, if you write these dissociation equations, you need to make sure they're balanced. Like here, there's 2 hydrogens, so you need to make sure there's 2 there. Now, the bases, they behave the same way. They would dissociate 100%, meaning if lithium hydroxide were to enter a container of water, or say Erlenmeyer flask or beaker, then it too would break down 100% to ions, where you would have Li plus 1 and you'd have OH negative 1. They would dissociate 100%. Okay, I mean, there wouldn't be any of this left at all. It'd be in ions. Wouldn't be any of this left, it'd be in ions. Wouldn't be any of this left, it'd be in ions. Okay, so let's do another one of those. Let's say you had Ca parentheses OH2, which is calcium hydroxide. It also went into a beaker of water. It would also automatically split into ions 100%. So you'd have Ca plus 2 plus OH negative 1, but remember there's 2 of them there, so make sure you put a 2 here. So this is how they would look if you wrote the dissociation equations. Basically just break it down to ions and make sure you keep up with the correct number. If you don't remember where these charges are coming from, just look back at your periodic table. You'll see that anything in column 1 is a plus 1 charge, anything in column 2 is a plus 2 charge. That's if it were to form ions. And I have these labeled. I know I just did that. I did the plus and minus 4 on this column because I like showing everyone how you have the transition there, because I always constantly get people say, why does it all of a sudden become negative? Well, I just put it there like that. This technically isn't a trend, and there are some inconsistencies in here as far as being plus 3. But anyway, that is what this is. Hopefully will be helpful in explaining what strong acids and strong bases are. Now if you have a weak acid, for example, let's say you have vinegar, acidic acid. Vinegar, let me write that down real quick, is vinegar acetate. So, all you gotta do is look on here and find acetate. Here it is HC2H3O2. Okay, now let's say that's vinegar, and you were to put vinegar into water. Now, technically there would be no dissociation equation written here, and let me explain why. Since this is a weak acid, it's not going to dissociate 100%. Believe it or not, some of it does break down, but what you end up having is something like this. You end up having a large percentage of the acetic acid not breaking down, so you would still have the HC2H3O2 in the water just floating around, but you would also have a little bit of the H+1 ion floating around and a little bit of the acetate ion floating around. So basically it's not going to dissociate 100%, just a little bit of it is. So just remember that weaks, you're going to have some ions that's going to form, but a very, 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 very small percentage, to whereas the largest percentage of it will remain unsoluble, okay, in the water. It's not going to dissociate into ions completely. Some of it will, but not all of it. So just remember, if you see a weak acid or a weak base, for example, if you see ammonia, NH3, and that's a weak base, there's not going to be one. So you just say no or just say none. But just remember that weaks do not break down. So anyway, I hope that this was helpful as far as trying to explain to you what weak acids and weak bases are, and what strong acids and strong bases are. So, but anyway, but it's nice that these are the only ones that are strong. If you want a little bit of a help in remembering the strong bases, it's actually kind of nice, because the strong bases make a B on the periodic table. I showed y'all this in class. You have LiOH, NaOH, KOH, RbOH, CSOH. Then all of a sudden you've got BaOH2, SROH2, and CaOH2. Notice that that makes a lovely B for base. Now, as far as your strong acids go, the only connection that you have really is right here. HCl, HBr, and HI. Those three are in a row right here. After that, you just have to memorize nitric acid, sulfuric acid, and perchloric acid. But anyway, just memorize those. But there's only 6, so that's not bad. Alright guys, I hope this was helpful.